So when working with trapezoid rule, I'm sure you noticed we're getting a better estimate, but it takes us a little more time, and that's kind of the trade-off. The faster I want to be able to do the estimate, I have to sacrifice accuracy. The more accurate I want to get, I have to sacrifice speed. Trapezoid rules are kind of a nice balance of, yeah, it takes me a little bit longer than RAM, but I do get a better estimate with the same number of shapes. Um, I will also say with trapezoid rule, it's a little bit easier to decide is our estimate over or under. With RAM, it depended on whether our function was increasing or decreasing and whether we were using LRAM or RRAM, and MRAM wasn't really easy for us to tell either way. But with trapezoid rule, we actually just need to look at concavity. Um, so to have an overestimate, if my function is concave up, and when I draw my trapezoid, you'll see that the trapezoid ends up being above a concave up curve. And so that would be an overestimate. But if I draw a curve that's concave down, when I draw a trapezoid, my trapezoid is under the curve and is therefore an underestimate. So to decide if my trapezoid rule is over or underestimating, all I need to do is look at concavity. So if I look at what we just found with the integral from 1 to 3 of x squared using trapezoid rule, which we got was 8.75, using trapezoid rule with 4 trapezoids, if I want to know is that over or under, I just need to know is x squared concave up or concave down. So if I'm saying my function is x squared, first derivative would be 2x, second derivative is 2, and on that interval from 1 to 3, 2 is greater than 0, so f is concave up, which means the trapezoid rule is overestimating. And that's how we can decide, are we over or underestimating using trapezoid rule.